A single negatively charged particle with a charge of negative 1.6 times 10 to the power of negative 19 coulomb travels at a velocity of 1 meters per second from right to left, parallel to the magnetic field B of strength 3 times 10 to the power of negative 5 Tesla. What is the magnitude of force the particle will experience from the magnetic field? So first of all, since the charge is negative 1.6 times 10 to the power of negative 19 coulomb, it means that we are dealing with an electron, just one electron, because the charge of electron is negative 1.6 times 10 to the power of negative 19 coulomb, and we know the charge of the proton is positive 1.6 times 10 to the power of negative 19 coulomb. So Q is negative 1.6 times 10 to the power of negative 19 coulomb. Velocity is 1 meters per second. And B, which is the magnetic field strength, is 3 times 10 to the power of negative 5 Tesla. It is moving. Velocity is from right to left. That's velocity. And magnetic field is going to be parallel to that one as well. Now the formula for finding magnetic force is B times V times Q times sine theta. B is the magnetic field strength in terms of Tesla, which is given. V is the velocity of the charge of the charged particle, and Q is the charge of the particle. Sine theta, theta is the angle between velocity direction and the magnetic field direction. In this case, they are parallel, so theta will be 0. So when theta is 0, sine theta is 0. And we know 0 times any number is going to be 0. So the force is going to be 0 Newton. So whenever we have parallel velocity and magnetic field, we have 0 force. But whenever we have perpendicular velocity and magnetic field, we're going to have the maximum force, because theta is 90, sine theta is going to be 1.